Well, it's similar to yesterday.
Are you recording?
Because now you should notice instead of an equal sign, I now have inequality signs. Okay? So it's very similar to yesterday, only now we have to figure we have and statements and or statements. Okay? So if you remember, and statements look like this. You have a number line, you have 2 points, and they're connecting together. That's what and statements look like. They come together, make a segment. Or statements go in opposite directions. So something like this, right? We did that back in chapter 1. We had compound inequalities and we graphed. Okay? So if you look here, the signs, anytime you have some sort of less than or equal to or less than sign, that's an and statement. Whenever you have greater than, equal to, that's going to be an or statement. And the only thing I could come up with to help you remember that is less than is and. Less than. It's good, right?
Wow, really creative.
Great. Look at this one. Great.
One.
Or are or statements. That's good. That's good. Okay? Why is that important? It's important to know that less thans are ands because if you have an and that's looking like an or, do you remember what that means? If you have a less than that looks like an or, no solution. So if you have some kind of less than sign and it's not looking like an and, it's looking like an or, that's a no solution. And if you have greater than, and you know it should be an or statement, but your or statement is looking like an and statement, it's coming together, that would be all real numbers, right? Okay, so that's why it's important to look at the symbols, because if it's supposed to be an and it's not looking like an and, it's looking like an or, no solution. If you have an or and it should be looking like an or, but it's not, it's looking like an and, that's all real numbers. And you'll get some of those on the assignment. So that's why it's important to know less thans are ands, greater thans are ors. Okay. So your steps are the same as yesterday. You still need to isolate the absolute value. You're still going to have to do that first. Okay? Your second step then, after the absolute value is isolated, your second step then is going to have to be determine if it's an and or. Okay? You do that after you isolate. Determine and or. And then thirdly, you're going to set up your two equations, or in this case, your two inequalities. So very similar to yesterday, but you have to determine and or, and then instead of checking your answers like we did yesterday, your graph will be, you don't have to check anymore because your graph will tell you if it's correct or not. Okay, so let's do some examples. So my first example, what do I have to do first there?
Add 5.
Add 5, very good. You need to isolate the absolute value. Right? Okay. Now, once it's isolated, then I determine if it's an and or. Is this an and or? An and because this is a less than sign, so it's an and, very good. Right? And what am I anding? I'm anding 2x plus 2. And then 2x plus 2, but we know on the second one, we have to negate the answer, right?
Negative 20.
Very good, negative 20. Now with inequalities, if I negate the answer, what's going to happen to my inequality? It's going to flip, yep. When you add in a negative, you have to remember that rule that your sign flips. So not only are you changing the answer, you're negating it, you're also changing the sign on that second one because of that negative. And then you just solve both of them. So subtract 2, divide by 2. So x is less than 9. And, right, subtract 2 again. Divide by 2. I get negative 11. So when I graph this on a number line, it should look like an and statement. So negative 11 is first because it's smaller, then my 9. And I'm greater than negative 11 and less than 9. The and statement looks like an and graph, so I'm good there. That's my check. Right? I'm not going to plug the numbers in and check. I'm going to check by making sure and looks like an and. Let's do another one. Let's do the one below it. I kind of have too many examples for these notes. I have found out during the other 2 periods it was a little bit too much. So divide by 2 first, right? Isolate the absolute value. You got to divide by 2 first. This is going to be an and or. And, because it's a less than or equal to. Okay, and what are my 2 ands? I have x plus 5 less than equal to 4. And my other one, x plus 5, but I need to change the sign and the number. Negate the answer, which changes the sign. So your pattern, keep the sign, keep the number, change the sign, change the number. That's kind of the pattern that you're doing. And then solve, okay? Just subtract 5. So x is less than equal to negative 1. Subtract 5 again on this side. X is greater than equal to negative 9. Put this on a number line and it should look like an and statement. Negative 9 is first, then the negative 1. And I'm closed circle this time, greater than negative 9, less than equal to 1. The and looks like an and, so I know this is good. Well, let's do an or. How about, what would be a good or one? This one. This is a good one. I like this one.
Where's that one? Where is it?
Okay. On the next, yep. What do I have to do first here? Add 3. Very good. Add 3. Okay. Is this going to be an and or an or? Or, because it's a great or then sign. Very good. It's an or. Okay. So I have x plus 5 over 3. Keep the sign, keep the number. X plus 5 over 3. Change the sign, change the number. Now, in order to solve for x, what am I going to undo first? The adding 5 or dividing by 3?
By 3.
Very good. I need to multiply both sides by 3 first. That gets rid of that. Then subtract 5. So x is greater than 22. Same steps on the other side, multiply by 3. That's going to cancel that out. And then subtract 5. Negative 32. Okay. Now it's an or statement, so when I graph this, it should look like an or statement, right? Going both ways. Hopefully it does that. Which number is first? Negative 32 is first, then 22. And I'm less than negative 32, greater than 32, so the or looks like an or, so I know this is correct.